Okay, so when we do sine, cosine, tangent for y, now we're standing in this corner, so everything we're going to do is going to be based off of everything that's here. So if we have y, again, this is going to be opposite now, and then this becomes the adjacent. Okay, so when we go back and do sine, cosine, and tangent, there's what we're looking for. So again, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent to get what we're looking for there. Okay, now the good thing is if you've done sine and you've done cosine for x, these two answers are just reverse answers here. So cosine of x is going to be 5 over 13, and then the cosine of y is going to be 12 over 13. Okay, and if you have to find tangent of y, where we've got tangent of x, tangent of y is going to be the same thing, but you just invert it. So it's going to be 5 over 12, because now we're doing opposite over adjacent for that part. Okay. Now, here's a good question. Does anybody remember how to use your calculator to, let's say the next question was to find x. Does anybody remember how to find what this angle is going to be using any one of these ratios? You do. All right, so let's flash back here. And again, we're going to use the calculators that's on the board because for this test, those are the calculators you get to use when we're going through and doing these. I'm going to borrow this one that's here because that's the one I've got here. Okay, if you have to find an angle based on one of these, you're going to have to do two things. Now, we've got this 12 over 13. We've got it here. But anytime it asks you, like this part, if it asks you to find this one and they ask you to find x, you're going to have to use this second or this shift button. So we're still going to do the 12 over 13 if we're going to do sine, but you're going to hit second and then hit sine, and then do 12 divided by 13. Okay, and that, can't see it there. Sorry for the glare. So if you do second and then sine and then put in the ratio, 12 over 13, it tells you this thing, we're going to round off to the nearest whole number, that this should be about 67 degrees. And the good news is it does not matter which of these operations you go with. If you want to do cosine of x, if you do second and then cosine, and then do 5 divided by 13, you're still going to get 67. If you do tangent, do second and do tangent, and then do 12 divided by 5, you're still going to get 67. Because again, it's the ratio of the angles that you get, so it doesn't matter which one you do. It's always going to be the same answer because you're basically comparing the sides of that's around an angle, so it's always going to be that exact same number. Okay, so if you have to find a missing angle, make sure you hit the second and then sine, cosine, or tangent, and then you put in your ratio, and then that'll get you the angle that you're looking for there. Okay, now if you've forgotten that one, that's okay. That's why we're going back and doing this because, that's why we practice. So. All right. Okay, so let's do this. All right, so everybody okay with the ratios and then how we find those angles? Okay, and you can do the same thing to find y. You can do second sine 5 over 13, do that. Or you could just subtract this from 90, and find out what y is going to be. All right, so for this one, let's do this. All right, so for this one, here's the triangle that we've got. Wavy triangle, but, still a triangle. We're going to find x for this one. Okay, and don't be the smart aleck on the test and go, found it. Yeah, don't do that because I will count that wrong. I'll laugh and then I'll count it wrong. So yeah, don't do that. Okay, so what you have to do is you've got to, again, based on this angle, you've got to label everything that's here. This would be the hypotenuse, and this would be the opposite side over here. Now we could call this the adjacent, but again, all you basically need is the sides that they've given to you. So if you have opposite and adjacent, that means we've got to use sine. So we're going to do the sine of 33 degrees equals x over 14. Again, we're talking about, if we've got opposite and hypotenuse, again, we know we're talking about sine. So we're going to do the sine of 33 equals x over 14. And if you get this number, this is where you can punch that number just straight in the calculator. So we can just do sine 33. So if you've got the angle, you just punch it straight in and get that. Now, one thing we'll probably need to make sure we do before we take the test, which if nobody messes with the calculator will be good. You've got to make sure that you're in the correct mode. And let's see if I can remember how we get there. And we'll do a calculator check just to make sure everything is good. Most of the time we can just hit second and then reset, and that will reset everything and put it back into this, to the, everything that needs to be. Okay, so we got sine of 33 equals 0.54. All right, so that means if we do sine of 33, that's 0.5446. And based on these, we're going to basically do cross products. If we put this over 1, so we can take that answer and then multiply by 14. Now, here's the big thing you have to do when you're doing these. You got two options on this one to make sure you get the correct answer, because you can do this a bunch of ways wrong. There's basically like 2 ways you can do this correct. So there's a bunch of ways you can kind of go wrong on this one. If you've got the sine or a cosine or tangent of this angle and you put it in here, just make sure that when you do that one, that you kind of put in there. Okay, so you can punch it in and get this number. After you've got this number, then you can multiply by 14, and then that way you know what x is going to be for that part. Okay, and for this one, since we're talking about length, we'll go basically 1 decimal place and get 7.6. Inches, feet, meters, whatever unit they specify for that one, that's what we're going to look for. Okay, now the main thing on this one though is you've got to make sure that if you do sine of 33, if you're going to do it all in one step, you've got to make sure you close that off and then hit times 14 to get the number that you're looking for. Because if you don't, if you just do sine of 33 times 14, the calculator is going to close the parentheses off there. So now you're not finding the sine of 33, you're finding the sine of 400 and something or other, which is going to give you a totally wrong answer. So when you're doing these, either one, find the sine of 33 and then hit enter and then multiply that by 14. Or if you want to do it all in one step, just make sure you close off that parentheses and then you can multiply by 14. So not a huge thing, but just make sure either you hit enter and then multiply by 14 or you close off parentheses. You've got to make sure you do one of those two to get the correct answers there. All right, let's do a little bit more. All right, so for example, 3. Said a little more. Okay, so there's our triangle. We're still going to find x. Okay, and again, you have to basically take the side that you have here, or the angle you have here, and label everything. Again, this is hypotenuse. In this case, this would be the adjacent side. So if we do adjacent and hypotenuse, that means we're going to do cosine. So it's cosine of the angle equals adjacent over hypotenuse. So that is 9 over 20. Okay, again, if the angle is missing, which we've got in this case, You got to hit your second button and then hit cosine. There we go. And then we'll do 9 divided by 20. Okay, so that tells us x is about 63 degrees.
How do you do that way equal sign?
Anytime you round it off, if it's not exactly, so if it was like if we punched it in and we got 63 on the dot, then you'd put it equal. Anytime you round it off, even if it's just one decimal place or anything, anytime you round it off a little bit, you always put the squiggles in there because it's technically you've adjusted the answer a little bit. It's not exact anymore.
So. What's the difference to cosine -1 versus cosine without?
Oh, so basically, if you've got cosine and then like the angle, then you just punch it straight in to get the number you're looking for. If the angle is missing, then you got to hit the second cosine because it's basically just you got to go in reverse because you got to figure out what that angle is going to be, and that's what the inverse kind of does. Question. Okay. Okay, so basically a Pythagorean theorem problem where we've got to find the missing side. All right, so again, there's your A and B values. So it's 10 squared plus 5 squared equals y squared. All right, so that's 100 plus 25 equals y squared. So 125 equals y squared. And when we square root it, and again, this is where you got to kind of be careful because again, if you check 125 on your calculator and you square root it, you're not going to get a perfect square root number. We get that, which means you're going to have to simplify it by hand to get what you need to get there. Now, they might let you leave that answer here and put in 11.1. They're probably going to tell you to leave it in simplest radical form. And then, so we're going to have to take the 125 and break it down. You can do it a bunch of different ways. If you just start doing the old factor tree, you got 5 times 25. And hopefully if you do that, you go, oh, well, there's 25. That's a perfect square. So if we've got 125, that's 25 times 5. You can take the square root of 25, make that 5, and then the 5 would be there. Okay, so we took 125 and started to break it down. So it was 25 times 5. And then if you ever run across a perfect square root number, instead of breaking it, so if we're doing this, if you run across this and this is a perfect square root, you can just square root this part. And then whatever's left over, well, that's just left over on the inside. Because if we had kept going on this, let's say if we hadn't done that, let's say if we had just done 25 times 5, then you could have taken the 25 and made it 5 times 5. So 125 would be 5 times 5 times 5. And if you remember with square roots, you're always looking for pairs. There's a pair of 5s. So the exit buddies, that 5 gets out. That 5 doesn't have a buddy, so it stays stuck on the inside. Okay, and I know we did that. And again, that's probably been 3 or 4 weeks ago when we were simplifying square roots. So you may have to kind of, knock the cobwebs off a little bit on those to kind of get through that part. Our whole unit circle trig, if you go back to this one, if we were going back to when we were doing this part of it, we had to do all these angles on here, the 30, the 45, the 60, the 90, all that stuff. let me show you where those angles actually come from. Okay, sorry about that. Okay, so special right triangles. There were two special right triangles that you did in geometry, and we're going to go back and pick up those two. And if you do or don't remember those, that's fine. We'll come back and show you what they were here. First one was a 30-60-90. And then the second one was a 45-45-90 triangle. Okay, and what we were doing, because this was a unit circle, and I probably should have drawn these differently. Oh, okay. So what we can think about on this one, and I'll just kind of go through this part. If you think, and I wish I'd drawn it the other way now and done this, but if this is your XY axis going this way, this was that radius we were talking about, the unit circle, that basically for what we're talking about now on the unit circle, this thing was 1 inch, 1 meter, 1 mile, whatever. And you could kind of think about the same thing back here. I should have drawn those in quadrant run, and I didn't. So same thing on this one. You can think that this is 1 inch, 1 foot, 1 mile. That's basically, if we laid out the unit circle, it would look something like this. That would be your circle going this way. And this would be your circle going this way, or something like that. That we're looking at this basically as being the origin for what we're doing. Okay, and we can go back and prove that. We'll kind of do that here in just a minute. Kind of get there, but basically it was this. Where we got all those numbers on the unit circle was, if you do or don't remember your 30, 60, 90 square roots on this one, that if you went from the hypotenuse back to the short side, which is opposite the 30-degree angle, you basically took the hypotenuse and you cut it in half. So if this side had been 4, this side would have been 2. If this side was 10, this side would have been half of 10. This would have been 5. So these two things are always doubles in half if you go from the hypotenuse back to the shorter side. And then to go from the short side back to the one that's opposite the 60 degrees, you take this side and then you multiply it by square root of 3. So when we were doing our unit circle, that 30, 60, 90 triangle, that's where basically this was this triangle that would have been here. Again, I wish I'd drawn it this way so it was over here. But basically that's our 30, 60, 90 triangle there. So there's our 30, that's our 60, that's our 90. So this part would have been 1/2. This part would have been square root of 3 over 2, which again, this is cosine, and that's our sine value. Which is, again, the only thing I did wrong on this was I drew it going this way. I wish I had drawn it coming over here to the right side, because that would have made it make more sense. Just wasn't thinking when I did that. Okay, and then for this one, now, what do you know about an isosceles triangle? What do you know about these two sides? All right, but they're also, one more word we're looking for. What do we know about the length on these two? What do we know about this length and then this length? Yeah, but then they're the same, right? Because it's a 45, 45, 90. That means that this length and this length would be the same. Okay, and that's where we were coming up with, if you go back to your old notes, that's square root of 2 over 2. So that's where they were kind of tying in those special right triangles. And that's where, again, if we drew this triangle that was here, I'll draw it over here on this side so it'll actually match up. If we had drawn this part with this 45-degree angle that would have been here, but that's a right angle, this would have been 45. This would have been 45. And again, these two things are the same. That's why this was square root of 2 over 2 and square root of 2 over 2, because basically those are those lengths that are there. Okay, so when they start doing some of that, you can do that, which means if they give you some of these angles, if they give you these 30, 60, 90 triangles, let's see if we can draw this. It's more like, here we go. So this basically would be more like in a unit circle. This is the way that a triangle should have gone. So that's your 30, 60, 90 triangle. They can give you something like this, and they would tell you, don't use your calculator to find the answers for this. You basically says, just use your trig ratios to find out what it is. So if it's a 30, 60, 90 triangle, basically, now we're still doing like hypotenuse and adjacent and opposite, that kind of thing. This one you need to think short, medium, and long. So this is hypotenuse, so this is your longest side. If you draw away from 30, this is your short side. And if that's the short and long, well, then this is going to basically be your medium side. Okay, and to go from short to long, you just take this answer and divide it by 2. So it's 8 divided by 2, so this side would just be 4. Okay, so we know the longest side is that value, which was 8. That was given, so we didn't have a variable with this one. The medium side is the y value. And if you have the short side, to go from the short side to the medium, all you do is you take the short side and then you multiply it by square root of 3. Okay, so again, everything kind of spins off the short side. If you've got the short side, you're going to take the short side and multiply by square root of 3 to get the medium. To get the if you're given the long side, then you've got to divide by 2 to get the short side.
What if you're given the medium side?
Ah, fantastic question. That's worth a Tootsie Roll. Or Starburst. Which one? You want to find? All right. Okay, if you're given the medium side, and you got to get back to the short side, because let's say they don't give you this one, they give you that this length is 8 or something like that. Now, if it's 4 square root of 3, so if you multiply to go from the short to long, if you go from the medium back to the short, instead of multiplying by square root of 3, you're going to have to divide by square root of 3. So if you got to go from the medium back to the short, instead of multiplying by square root of 3, you're going to have to divide by square root of 3. So they told you that the medium side was 10. To get back to the short side, it's basically going to be 10 divided by the square root of 3, which means you're going to have to do like we did the other day on the pink sheet when we were working through the stuff. This is where they're going to ask you to rationalize this number. So again, the shortcut is you're going to move that square root from the bottom to the top. And on the bottom, you're going to leave just that number. And that's kind of an ugly looking number, but that's the number that we would be looking for in that case. Okay, so hopefully they'll give you either the long or the short side, because if you got either one of those two, everything else is easy. If they give you the medium side, it's just gonna it's not really hard. It's just gonna be kind of ugly, because that's not a very pretty answer, because it's a radical and it's a fraction, so it's just all kinds of ugly. Yes. So we were doing an example here. What if this thing was 10 inches long? Then if we got to figure out what the short side is, we got to take this 10 and divide it by square root of 3. Okay, so again, if you've got short or the long, it's easy because you multiply or divide by 2, and then once you've got the short side, you just multiply times square root of 3. But again, if you've got the medium, then you've got to divide by square root of 3, and hopefully it'll be a number that will clean up a little easier. Usually if it's a multiple of 3, then that makes the work a little bit nicer when you go through those. Okay, and then if it's 45, 45, 90, it's basically the same thing. Okay, so let's say this is 8 inches and they ask you to find x. Oh, actually, let's go there. Let's go with, hang on. Let's swipe it up here first. Let's make this x, make this 8 to start with. The next one we'll do it backwards and kind of go from there. Okay, now they probably wouldn't ask you to find this side because if they did, it's basically known that that's the same thing. Okay, now, and this is honestly one of those that if you want to see the shortcut, we'll do this. We'll kind of do it the long way first. And then once we do the long way, you can kind of see the shortcut, and then you'll kind of know what's going with it here. So if we just did Pythagorean theorem, it would be 8 squared plus 8 squared equals x squared. Okay, so if you do 8 squared plus 8 squared, that's 64 plus 64, that's 128. Okay, but we've got to break this thing down. Again, we're going to kind of take the long route so we can kind of see what the shortcut would be. We're going to square root 128, and we're going to square root the x squared. We've got to take the 128 and break it down. Okay, and I'm going to do this one on purpose this way for the numbers. We're going to do 64 times 2, because that's 2 64s, right? So if you do 64 times 2, what's the square root of 64? That's 8, right? That 2 doesn't have a buddy to break it out, so that makes it 8 square root of 2. And it will always be that same setup that you're always going to do some numbers. If we made this 18, this would have been 18 and 18. We'd have squared those numbers, but when you break it down, because it's 2 of the same numbers, it's basically going to be 2 times whatever that number squared is. So it's always going to work out that when you do this, you're going to get these same 2 numbers twice, which means it's going to be 2 times that number, but that's going to be a perfect square root. So if they give you these are 8, well, then the shortcut is for this one is just 8 square root of 2. So anytime they give you either one of the legs that's here, you just take that number and you just multiply it by square root of 2. If they give you the hypotenuse and you've got to go back this way, then you would wind up just dividing it by square root of 2. So everything in the 45, 45, 90, you're either going to multiply the short side by square root of 2, or you're going to divide the hypotenuse by the square root of 2. And again, if you divide it by square root of 2, if it's a whole number, you are going to have to rationalize it to kind of get the part that goes from there.